favorite demo in chemistry of all time. It's so explosive, so exothermic, that's why we have to be outside. Does anyone have any asthma or breathing issues?
Not yet.
Not yet. Okay, if you do, there's just a lot of smoke that's created, so we would just need to make sure we weren't standing directly in front of that. We're outside, in fact, because if we did this inside, I'd have to set up a blast shield so nobody would get hit in the face with liquid iron, as well as we'd then have to evacuate the classroom for the rest of the afternoon. And of course, I know you guys want to go back there and learn more chemistry. Yay! Of course. Okay, good. I'm going to get this all together. First things first. Kelsey is going to line the inside of this clay pot with aluminum foil. Okay? I don't care. Doesn't matter. Okay, so just shove it down. Give her a hand, Donnie. Don't just stand there and be useless. Like all men. Don't treat me like an invalid. I can do this.
An invalid, ha!
Oh, you got the foil. Good job.
No, I'm good. Just make sure it goes all the way down and try not to tear a hole in the bottom.
Yeah, she already did.
Okay.
It doesn't like go down.
Oh, you can show your parents. They'll be impressed.
Yeah.
Proud. Mine always are.
There we go.
Okay. Good. Give me back my clay pot. Don't leave now. It's just getting exciting. Okay, inside this clay pot, we're going to mix some stuff up. First thing I'm going to throw in there is some iron 3 oxide. Guys, we see iron 3 oxide every day, but since we're not all science nerds, what do we call it? Rust. And you can see, I've already used this scoop on there. You can see it's just powdered, ground up rust. So what we're going to do is we're going to put 6 scoops, but we're going to make them Schmidt-sized scoops. Okay? 2, so pretty big. The more that we can put in here, the more liquid iron we're going to produce. I've lost count. Is this 4?
3 for sure, man.
2.
1. That was number 3.
Yeah, right. You guys are going to get me fired. Correction, I'm going to get me fired. Okay.
Literally fired.
Next thing.
With fire, yeah.
What I'm going to do, guys, next is I'm going to put in some powdered aluminum. So this is just like the foil that Kelsey used to line the pot, except for it's all ground up. So powdered just like our rust is, okay? And we're going to put in 2 scoops of that.
Schmidt-sized scoops.
2 scoops, right? Okay, and now it's like, I'm just going to mix it all up, okay? So I'm just mixing the powders together. So it's like a delicious cake mix, perhaps. Oh, get some all over me. That's no big deal. Red velvet cupcakes, that's right. This is how they're made. Okay, oh, I got some iron in the aluminum. Don't tell anyone.
Oh.
All right, next thing we're going to do, guys. When I was a kid, my dad and I, we used to make blueberry muffins Sunday mornings, okay? And he taught me how to make muffins. And when you make muffins, you mix all your dry ingredients together, and then what you do before you put the wet ingredients in them is you make a well. So you just sort of make an indentation in the dry ingredients. Now, we're not going to put wet ingredients in the middle of this, okay? But we are going to put more ingredients, okay? So I'm going to throw that down. I'm going to put in...
I want to show this to my parents.
I'm going to put in another scoop of powdered aluminum right in the middle of the well, just one.
Yeah, just one.
Okay, and then the compound that we really care about, oh, I thought I lost my scoop, is potassium chlorate. And guys, we're going to see, you're going to be best friends with potassium chlorate by the end of the year, because we're going to use it in a lot more explosive experiments. Okay? It is going to be great.
Where can you get that?
You can't. I can. So what I'm going to do is I'm going to mix the aluminum and potassium chlorate. Remember, I put that in the well, right? So I'm just going to mix those together, and I don't want to mix in the iron or any of the other stuff. So I'm just mixing in the well. Now, for the tricky part, okay? This is the part that I messed up on this morning, and I don't like messing up on this reaction because it gets a little scary. Here we have magnesium ribbon, okay? What we're going to use this magnesium ribbon for is to make a fuse. Okay?
Doesn't magnesium burn at like 5,000 degrees or something
No.
crazy like that?
I can light magnesium on fire with a lighter.
No, I mean it burns really hot. Like
It does burn hot.
Yeah, okay, that's what I meant.
And bright. So that was my next point. How many of you guys have seen magnesium burn before? Oh, Adol's here. Yay. Yeah, exactly. It burns. When it burns, it gives off this really super bright white light. And if you look directly at it, you'll end up burning out your retinas. So please don't do that. Okay? Now, what I'm doing with this fuse here, and we'll talk about this a little bit more when we get back into the classroom, but what I'm doing is, one, giving myself some time to light this and then run away.
Very fast.
Okay? One time I didn't make the fuse long enough.
Oh.
That didn't work out so well for me. Okay?
What happened?
Well, it basically went off in my face.
Oh.
Yeah, not good.
Who needs
Okay?
eyebrows?
Yeah, well, it would be a lot worse than losing eyebrows, that's for sure. Okay. Oh, hopefully that works. Damn it. All right, what I'm going to do is I'm going to stick this fuse, the coiled part, I'm going to stick it down in my mix of potassium chlorate and aluminum. Okay. Yoink. And I want to get it standing as straight up as possible, which is always the tricky part. Okay, so what I'm going to do is, since we've all moved away, I'm going to bring this over to our pan here, and I'm going to light it on fire. Can you put that in the bucket, please? Okay, guys, I need everybody on the sidewalk.
I'm on the sidewalk.
This is the one I actually want to record. I thought she'd be quick.
Sorry, heads up, sorry. There, that wasn't anything personal. Run and flip flop. All right, what I'm going to do is I'm going to light this magnesium on fire. We're just going to look at it using our periph, not directly, okay? And then hopefully once it burns down, fingers crossed, we're going to get some thermite. Now this reaction, guys, is still used today in practical applications, not just Chem 30 labs. What we use this reaction for, and by we I mean not us, other people, is to weld together rails on a railroad. Okay? It's obviously done in a much more controlled environment, and we're going to see iron splatter all over the place. Obviously, they get it to go straight down to weld the ties together. All right? So this reaction is actually still carried out in the real world. Are you guys ready?
Yeah.
I wish this job.
Run this pit. Directly at the magnesium.
Actually, it's not that bright this time.
No, it's not that bad. Okay, here we go. Here we go. Oh! I think we added a few extra chunks. Don't tell your parents. Okay.
Oh, wow.
Wow.
So again, if you're bothered by smoke, don't approach that, but as soon as I find my shoe.
Oh, yeah. It's your
Okay.
left.
So this reaction, it's done. You guys can, if you're wearing shoes, just be careful that there could be glowing embers around. You can come up and take a look at what was produced, okay?
Can we make it bigger next time?
No, that's what I'm
Hey, cameraman.
Alright, check out the bottom of that pot, still glowing hot.
Someone touch it.
Or don't.
That's a terrible idea.
All right, so you can see this chunk down here. That's liquid iron. That's molten iron. Okay. One of the questions that you're going to be asked is, what temperature does this reaction get to? All right. And when you research it, you'll find that it gets pretty darn hot. So hot that if I were to even pick up this pan, okay, underneath where that molten iron is, it would burn my hand, just like the same way it would if I took it out of the oven. Okay, that's how hot it is. It's conducting that heat all the way through the powder mixture we have in the bottom, as well as the steel pan itself. Okay? No, you can't poke it with a stick.
Because it'll light on fire.
Yeah. Okay? Fantastic. Let's get a round of applause for explosions in chemistry. All right.